Today's episode is proudly sponsored by Pyxis Lab, the leading manufacturer of inline and handheld monitoring technology for fluorescent tracing chemicals. Pyxis has quickly become a trusted name in the water treatment industry, offering high-quality inline and offline analytical devices that measure key parameters. Pyxis believes that water professionals deserve better. That's why Pyxis endeavors to bring you the best when it comes to the tools you use to monitor your water treatment programs. Have an application? Pyxis has a solution. Go to scalinguph2o.com/Pyxis to find out more. Once again, that's scalinguph2o.com/Pyxis, Pyxix. Pyxis, because water professionals deserve better. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. And I'm going to say welcome to the award-winning podcast, Scaling Up H2O. I am your host, Trace Blackmore, certified water technologist. And if you joined us last week, I let you know that we received a great award, the Innovation Award, presented by the Association of Water Technologies to the Scaling Up H2O podcast. And without a doubt, that was because of the Scaling Up Nation. So such an honor. We are an award-winning podcast now, and I am so proud of that. Thank you for listening to this podcast. And as I probably said last week, because I'm still just so excited about this, that not only did we receive an award, it was a recognition for all of you, the Scaling Up Nation. I love that we have a community of industrial water treaters where even though we physically don't work together, we are all improving this community one water treater at a time, and just so exciting to receive that award. So thanks again for everybody who was involved with that. And Scaling Up Nation, I really want to recognize you as the recipient of that award. Well, last week was the Association of Water Technologies conference, and one of the things that I love to do is walk through the exhibit hall. So many people there, so many new ideas, so many breakthrough ideas, and I think I shared on an earlier episode, I want to get one idea. That's my only checkbox. What's the one thing that I'm going to work on from this convention? And folks, I've probably found about a dozen of them, but of that, I'm going to choose one, and I'm going to make sure I see that all the way through. Now, and if I get to go back to the other 11, that's awesome, but I'm going to make sure I do at least one. And everybody in my company that goes to the conference, I hold them to the same standard, and it's amazing how much you can get done when you don't try to do too much. But something that kept coming up during the AWT was problems with testing equipment. And folks, spoiler alert, it wasn't the testing equipment. It wasn't the reagents. It was user error. So I am going to encourage all of you to go back and read your procedures. Now, you might not realize it, but there are chemists that are constantly refining the procedures to try to make them more effective and more efficient. If you have a spectrophotometer, there might be an upgrade to the firmware that makes your test more accurate. So I want to challenge everybody to check their meters, check their firmware, check your procedures, make sure that you are running them correctly. Maybe there's a new way that they found it eliminates some sort of interference. So here's how I look at my testing equipment. First off, I want you to be confident in your testing equipment. And again, so many conversations last week around this. So the first question I want you to ask is, how well do you trust your testing equipment? And however you answered that question, the follow-up question is, how do you know? What have you done to prove that whatever you are using is either working or not working? When was the last time that you did that? I truly believe that the real distinction between water treaters and somebody that just runs tests is how we used our testing equipment. I believe that our test should only be used to confirm what we already know is going on in the system. So when I get to a system, I do not open up my test kit. I set it on the floor and I walk around and I try to create a hypothesis of all of the information that I am taking in inside the mechanical room, outside where the cooling tower is, wherever I am. I'm looking at how much product I had last month versus how much product I have this month. Maybe the system's bleeding. Maybe it's not bleeding. Maybe the controller has some sort of an alarm. I'm taking all of that in and I am forming a hypothesis. What do I think is going on with that system? And it's only until I think I know what's going on with that system that I even open my test kit. And then I start running the test. Now, we can do an entire show on this. How do we make sure we're efficiently running our tests? Because the quicker you can run through all of your tests, the more efficient you're going to be, and you don't get paid really to run those tests. So if you can shave time off of that, that's really going to pay you back in dividends. But that's another show. I just want to talk about how well do we trust those tests, and are we using that to confirm what we already think about the system? So here are my top 5 items to do to ensure that you have faith within your test kit. So the number 1 item is you need to make sure everything is clean. When I test this water at this facility, it needs to be this facility's water, not the facility's water residual that was from the last place that I sampled, or maybe the last 10 places that I sampled. So as clean as we can get everything that we're using, that's our glassware, that's our plasticware, that's all of our meters. Most of our meters, if we're speaking about spectrophotometers, they're shooting a wave of light through. Well, that light goes through hopefully a clean glass specimen, and then it gets read on the other side. Well, if it's got to poke through all this dirt and debris, you're not going to get accurate readings. So make sure that everything is clean. I added earlier in the top of this program that you want to make sure that your meters are updated to the latest firmware. And you might be surprised how many updates you have missed, which is why it's good to do a periodic checklist on your test kit. And one of those items should be replacing your batteries, making sure that you have the latest firmware. And I have a pop-up that comes up to remind me to do that. Otherwise, I would probably not remember. And now I'm 7 firmwares out of date. Hopefully, I'm not that far, but it could happen. So we want to make sure everything is clean. We want to rinse. Number 2, we want to rinse more with the sample that we're actually testing. I want to make sure that all I have within that sample vial is the water that I am testing. Now, if I am getting that sample from a bypass, maybe we're at one of those locations, and this is nirvana, when a customer plumbs all the different sample lines up to a sink so we can just set up in one location and the sample comes to us. Those are great. But I've seen so many people just turn them on, grab their sample, and turn them off. And there's about 40 feet of pipe that water has to go through. Well, they're not getting true sample water. So we are going to make sure that we've got actual sample water that we want to test running through that sample line. And then we are going to triple rinse with that sample. And we're going to go ahead and fill that up to whatever sample level that we need. Number 3 is deionized water is your friend. Deionized water you will use to rinse and make sure that your test kit is ready to go for the next test after we're done testing. But it is also how we are going to dilute samples, how we are going to dilute out interferences. So as you're reviewing your testing procedures, you'll see certain interferences. If you have them, you've got to dilute the sample. Well, you can't dilute that with more sample. You've got to dilute that with DI water. So make sure your DI water is actually DI water. When was the last time you checked conductivity on your DI water? And if you put really nasty water in that DI bottle, well, that might have spent your resin. If you don't test it, you don't know. So make sure you trust your DI water, do a conductivity on it, and it should be really close to 0. I just mentioned this, but number 4 is to make sure your test kit is ready to go. So when I close my test kit to take it away from this location, getting ready to transport it to the next location, it is ready to be opened and started. Everything's in its place. Everything is clean. Everything is filled. I don't want to have to waste any time trying to find anything in my test kit or something is not ready to go. And the last thing, number 5, is to actually test your tests. I love doing this at our office. We'll take a sample and we'll make sure that we know what's in it, and we will have everybody test it and see what everybody gets. If you have a bunch of people at an account, do that with your customers. And you'll see if you got 3 people, it's highly likely you're going to get 3 different results. And that's a great way to then have a procedural conversation and talk about, oh, we're not measuring properly. By just going over a mil, this is the percentage that you're going to be off, or by going under a mil, this is how you're going to be off. By not rinsing properly, all the things that we just talked about, it's a great way to confirm all that with actually testing your test. And folks, we've got so many great manufacturers and vendors of great testing equipment within the Association of Water Technologies. Please reach out to wherever you are getting your testware from, because they would love to help you. So I hope those 5 tips help you become more confident in the tests that you are running. Well, Nation, let's go ahead and transition to our interview. My lab partner today is returning guest Michael Solar, Vice President of Business Development at Bowen Engineering Corporation. And Mike also serves on the Executive Committee of the International Water Conference. Mike, welcome back to the show.
Thanks, Trace. It is a delight to be back and always have a good laugh and actually a great technical conversation.
Well, it's hard to believe it was well over a year ago that you were on the show for the first time. That was episode 307, and we were talking all about how to write technical papers. And I don't know how much feedback you received, but I've received several comments where people said, I was presenting a paper or I wanted to present an abstract to make sure it got picked up. So many people benefited from that conversation. So thank you for that.
You're welcome. I'm happy the audience enjoyed it as well. It's just a real passion.
If you haven't listened to that, again, that's episode 307. And Mike, you did a great job of breaking down how to go about that and even how to pick out a name. I mean, how do you know what the right name is for a paper?
You got to have a grabber. You have to have something that says, well, it's the headline on the top of the article. Why would I ever read it? It's as simple as that. But it's hard. It's like a poem.
Exactly true. And, you've got these people in the selection committee that they're trying to present the best show that they can. And the only thing they have is just the title at first. And then that title's got to grab them to get them to go into the abstract. So again, lots of great tips on that episode. We were talking specifically about the International Water Conference back then. You were on the executive committee and you and I got to work together. I got to be the keynote speaker for the International Water Conference last year. What a treat that was. And oh my gosh, you guys were so amazing to work with.
Well, I appreciate you bringing that up. The thing that made that particular conference was every day you were engaging with a different group of people, whether it was a technical folks or an owners group or a provider of services, and you were bringing the myriad of subjects that are covered at the IWC, the International Water Conference, whether that's PFAS, which we've been up to for 4 years, or it's industrial wastewater, or just plain old water. How do you treat good drinking water in some ways? Now, there are other competing or other conferences that offer something, but ours is unique in that ours is a technical paper conference and you can get those write-ups, but it's the people. Trace, it's the human beings that show up and engage with each other. And that's always what makes it fun.
Now, you are serving on the executive committee. What does the executive committee do?
The executive committee's role is to assure that we have current and relevant programming for the conference. What is coming? And we meet on a monthly basis at the executive committee. And our mission is to assure that we're looking 2 to 5 years ahead. What is coming? What are our clients having to deal with? What are regulations that are coming forward? What are sustainability issues or opportunities that weren't considered or available before? And how do we highlight those and get practitioners to talk about not only the great things they do, but maybe some of the failures that they have learned from? And that's what we do on the executive committee. And we're supported by 60 other industry partners as our advisory group. So this is not this closed society communicating amongst ourselves. No, we really enjoy this advisory group because they come from all sectors of the water business.
We will have information about the upcoming conference on our show notes page. But since we have you here, tell us what to expect this year.
This year, we have a slate of papers that, again, deals with very difficult industrial water, wastewater. We have at least 2 full sessions on sustainability. It's a big issue. Now, when I say issue, it's an opportunity that our food and beverage clients are using to how do we reduce the total volume of water used by each user? And then what do we use what is called wastewater, but it's used water for something else? And in addition, we have a significant number of papers on membrane technology, whether that's RO or UF. And then we have a boiler section because boilers are their own special breed and come with their own special requirements. So I would encourage people to go to the International Water Conference website and look at the papers. The program is all posted and ready to review.
We'll make sure to have that direct link on our show notes page. So if people didn't write down where to go, they know where to go and they can find you. Well, as I said, it was May of 2023 that we had you on the podcast. What have you been up to since then?
A tremendous amount. And that's a short answer to a really interesting question. But here's what's been going on. In the last 15 months, we at Bowen, and my role specifically, have been to work with the wastewater clients that are non-municipal, particularly for my sector, and deliver projects in a collaborative way. So there's a couple of methods of delivery. You have to design it, bid it, build it, give a price for what's drawn on the drawings and in the specifications. And then there's the collaborative method, and it comes in all forms and fashions. And I've spent my time in that regard because it comes down to how we engage with our clients and our clients engage with us. When we understand what the client's business goals are and the fact that they need water to do what they're going to do and wastewater or used water to finish with what they've got, then we can come up with better economical, schedule-driven, and operationally driven solutions. And that's what I've been spending my time on.
Well, we're going to get into a paper that you recently submitted, and it's all about what you just spoke about. So let me make sure I get the title exactly right. So I'm reading it: Treatment of Aerospace Machining and Inspection Wastewater. Sexy title. You're the master of titles that got you into the conference. So tell us what that paper was about. Why did you write it?
I first want to make sure that the audience knows that this was not a uniform paper by me. There's another fellow by the name of Chris Stanfill, and he's down in the Carolinas now, and he is the master of this chemistry. And I was the builder, and our teams were the constructors, but Chris really understands this as well. And he was the fellow who helped me put this paper together. So Chris is my partner in this. Why we wrote this paper was there we had this industrial client in the Midwest. Can't repeat the name because of the sensitivity of it, because it's related to national defense as well. So I'll just offer that. So it's not to be evasive, just need to be cautious. What they asked us to do was they were developing some new lines of machining, and their existing treatment system was a single large treatment system that covered many, many parts of this plant. And as they changed their business and went to smaller plants to produce different products and projects, they were getting different quality waste streams with different constituents. Our job was to come up with a treatment process to address the new processes. So they not only had different metals, they had different liquids, they had different locations, and they had different volumes. Well, we know from treatment, when you understand the constituents and you understand the volumes, you can start working with it. But there was the variability that caused this particular project, and this the reason we wrote this paper, to be very interesting and I think educational for the readers of the paper.
Something that I found very interesting is we've talked about wastewater on this show several times, but this is so industry specific. And I know there's somebody listening that wants to go after this particular piece of business, or maybe they know somebody that works somewhere and they know they can do a good job for them, but they need to make sure that they understand that industry, that sector very well. So the question I want to ask is, how do you make sure you know what you need to know about a particular industry as you're going after them as a potential client?
Great broad question. What I would recommend to folks that would want to go into something like this or some other specific industrial industry is study what they get paid to deliver and where they get paid to make it. Because where they make it, the product, and how they create that product with solids, liquids, gases, and discharge matters. So we have to understand the business, and I say this all the time, but it's really the foundation of what I choose to do. When we understand where their business is and if they need to pre-treat, so industrial discharge many times goes to a POTW, a publicly operated treatment works. Well, there's a standard. It's called 40 CFR 433, and that standard is a federal regulation for metal finishing point source categories. There's a whole large paragraph about what treatment requirements and what limits of discharge pre-treatment before it goes to a POTW where it has to get to. As an example, in this case, we had really 4 primary constituents of concerns. We had chromium, we had zinc, we had total petroleum hydrocarbons, and we had cyanide. Well, in a normal wastewater stream, you won't have cyanide for sure, but generally you won't have chromium, but you'll have lead and copper. So you understanding the dynamic and the difference in the constituents. But on this project, I'll give this as a specific example because you can apply it to another industry. Chromium, not a problem. High alloy metal in the aerospace industry, not unheard of. Dye penetrants, didn't mention that before, but dye penetrants are corrosive in their nature because they give a value in their nature. Then you have oils, all of that. But one of the things we found was zinc. There's no zinc in manufacturing of aerospace products. There's really not. Think about what that product is. What we found was when we analyzed the facility, the zinc came from galvanized piping in the system that was delivering the wastewater to the end of the pipe. There was a permit requirement to have zinc at a certain level. But here's the variability in the flow. In many municipal flows, I'll call it municipal flows, or in predictable flows, you don't have large constituent variability, you'll have large flow variability. In the total hydrocarbon, we have a 780% differential between low flow to high flow. And compared to the high flow, we need to remove 98% of that material. So when you put these two graphs going together, it becomes a really interesting multivariable experiment, quite frankly. How do we develop a system that allows flexibility but maintains compliance? Then we have to address the zinc, the soluble zinc. So we address these oils and these greases and then the particulates that come off and pass through whatever filtration methodology, but then you have to meet the soluble permit limits, not just the TSS limits and so on. By way of example, my recommendation is spend time. This is the time to understand the business and what they do and where they send their stuff and where their expenses are. What do they get paid to do? Is it a difference between capital and operating expense? That you've had many people on the podcast talk about understanding that tenuous difference because that's what drives the business, but it also drives the intellectual solution for the operators. And that's who we have to remember. At the end of the capital project, the operators have to make this thing do what we want it to do. And as long as they are given those knowledge tools, physical tools, and solutions to fix and monitor the problem, they'll get what they need.
It's a great way to look at any project and making sure that you're relating that back to what it is that they're getting paid to do, where they're getting paid to do it. I love that. And that puts everything in focus. But you brought up something very interesting. We have this variability of flow. We've got low flow. We've got high flow. You're doing a lot of surveying, a lot of observation during this initial period. What are some things that you're looking for? And now that you have all this information, application, how do you then go about creating your first stab at a solution? Because let's face it, normally the first thing we try, there's something a little bit better out there. So what does that process look like for you?
The process looks like identifying treatment solutions that can solve the primary problem that we know. So the best thing we can do is to throw everything on the table and then start taking cards off. And we'll get down to, in this case, we ended up with 3 viable metal removal solutions and 3 THP solutions. We weren't concerned about the zinc because that's an easier process that's well documented. And that's what I would tell you is we did 2 things at once. We said, what are the solutions that are available? And then what are the easily notable, repeatable solutions that we already go? Let's not spend any time on those. You pull that solution in, that's on the zinc. We did an absorption approach. The other ones, we said, okay, if we do separate treatment for petroleum hydrocarbons, and then we have a separate system for the particulates, what's the cost of that? And what does the footprint look like? So we start with process, then we continue to what are the options for process flow. Then we start looking at general arrangement and footprint. And then we stop and we go, okay, let's create a matrix of potential costs, capital costs, and then operating expense. And here was the education that we really worked with the client on to get the client educated and to help them understand when we give out cost, these are precision-based cost, not accuracy-based cost. So in the beginning, when we're dreaming, we have a limited number of solutions that we're going to investigate. Well, that variability of what that precision-based cost is pretty big. It could be 40%. And there's a great organization out there called the American Associated Cost Engineers, and they have a wonderful article, 18-97R, that explains why these variable solutions matter and how you can have confidence in them. So when we did that alternative evaluation, that helped us guide our decision making because let's use the concept of Pareto, 80-20 rule, whatever you want to call it. Nevertheless, when you look at the process flow diagram, they come with different cost bases and complexity bases for design. Some have more ability to deal with variability in flow or quality of constituent. When we put all those numbers together, we weighted the capital expense versus an operating expense. Is it an internal operating expense? Or in this case, from absorption perspective, we found a very economical external solution. So that took a burden off the client. When we put all that in there, the 80-20 rule helped us get down to what's the most economical, acceptable, compliance-based solution. And then we really got down to, you'll appreciate this, for this project, we evaluated 12 different economic models, and we got down to 2 viables. But we had to do 12. Well, we didn't have to. We chose to do 12 with our client so that they could understand both their internal and external operating expenses.
Mike, after all of that, what were the primary constituents of concern? And then how did you figure out what you were going to address and how you were going to evaluate those?
Trace, the primary constituents of concern in this particular application was total petroleum hydrocarbon and particulate metals, and then finally soluble zinc. There were 7 or 8 other constituents, but they were not of the level of concern of those 3. When we began looking at the treatment options available, we were able to work with the operations team and determine that to treat the metals, we could do a source reduction before it even got to us because that was inside the plant. So we looked at the option of changing out the galvanized pipe. We looked at adsorption with just basic ion exchange. But then we also looked at an evoqua solution because of an external operation that could be farmed out. It was also an absorption, and it would take out the zinc with a specific ion exchange. But when it came to the THP, there were 3 other additional options. We have 3-phase centrifuge, well documented on its ability to separate oil and water that has been emulsified together, ultrafiltration, but then we also looked at what if we could take out both the emulsified THP and the metals together. Well, then we looked at doing emulsion breaking with dissolved air flotation. And then we also looked at oil and water separator. We also, when we looked at that, the last one we looked at, which is actually one we chose, was ultrafiltration. It's a very robust solution, came with a little bit more upfront capital costs and a little bit more operational energy cost, but we did it in one step. So we had less equipment, and the operations team was familiar with UF. They weren't as familiar with DAF and doing breakpoints and so on. That was interesting, but it didn't cost any less. So that's how we went through the matrix and we evaluated the process flow diagrams.
So by doing that, you eliminated things based on manpower, based on the ability for them to want to afford it. All of those things, you came out with UF. How did you then prove that that was the right decision?
We showed the diagrams with the different process flow diagrams. And when we counted the unit processes, it was less unit processes. And when we did the economics between the types of piping and lengths of piping, it became a better capital expenditure. To remove the zinc, we chose to recommend, I should say, the Evoqua adsorption solution because it was an external expense and it was a controllable and they could get a long-term solution because as we all know with adsorption, it has its useful life and then has to be replaced. That process was very beneficial because they had a prior relationship with Evoqua. So when it came down to it, and we talked to the business managers and we said, what's your goal and how do we do it? If we could build a smaller footprint and we could use less equipment, okay. The one thing that we had to do was we had to put the wide spots, the equalization tanks had to be a little bit larger because we were going to use multiple flows. But those EQ tanks also allowed us to make some factoring decisions because you would get the mixing between higher concentration and lower concentration versus higher flow and lower flow.
So they give you the go-ahead, you start building it, you put it in operation. How do you prove that this was the best decision? See, Mr. Customer, we knew what we were doing. Here's the benefit of it.
Great question. Interesting answer is you can't prove a negative, but what you can prove is when you deliver us the water that you say, we will deliver the water on the backside that we promised. That's what we can do. And so what we chose to do was we said, here's a defined price for the work that worked within their pro forma, get the business people doing what the business people do. And then we were going to prove to you that it will do what we say it will do. And that's how we went about that. Because it boils down to this, in that when you create a history of why decisions are made, that can be reviewed by someone else in 5 or 10 years after we're doing something else, they can then understand if the next decision has to change because the why is different. That's what we choose to do. And the bottom line is you give us the kind of water that we anticipate and we deliver the kind of water you need so that you're in compliance. Boom, that's a win.
So how do you ensure that you are staying in compliance? What items did you put in place, did the customer put in place that everything is working properly, everything's being maintained properly, and there's no fines down the road?
They do the daily monitoring of the discharge and the monthly average. Those are the national discharge standards and the local discharge standards from that plant to the POTW. So those recordings of samples and then the monitoring along the way, the cleaning of the equipment, they have those good records. And because they're industrial user, they understand the importance of maintenance. It's a very short answer, but it's really that straightforward that the requirement by the POTW for this monitoring and reporting it to them, that's part of their agreement to have a discharge permit to the POTW as an industrial user. So there's motivation to remain in compliance. And what we encouraged them to do was plan for regular maintenance. That's not a surprise, but plan for having spares that will go bad. whether that's pumps or seals or piping or otherwise. And when we had an upset or when they would have an upset, because that's the reality of it, we had a containment area within the footprint of general arrangement that could accept quite a bit of liquid while they fixed an issue or had to dump a tank to fix a leak or whatever it may be. It's a roundabout answer to your question, but it's a 1 or a 0. Either they're in compliance or they're not. And what I would tell you is this client and many of our others, they're not running at a 90% close to maximum discharge. They want more margin than that. They want about a 60%, 70% regular operating range because they know they're going to have this variability. They're just not sure exactly when that sample will be taken and when the operations will be occurring in the facility.
I love that your customer didn't want to go to 100% capacity. They're saying, hey, we've got to maintain these things. We're going to have to bring things off of line. And that got built into the design. I can't tell you how many projects I've seen value engineered where any extra capacity was out. And now what do? You're up against the wall. You don't have time to take things offline. I love that this customer had a clear mindset around that. With that in mind, knowing we're going to have to talk to a customer that doesn't want to build that in. Maybe that is an extra expense. What's the best way to have that conversation?
The best way, I'm going to answer it this way. I don't know if there's a best way, but I will answer it in this way, that an effective way to have an effective interaction is this. First one, when you meet with your client, you want to establish some rapport. The best way to establish the rapport is discuss roles and responsibilities at the outset. Second, explain to the customer their job is to make decisions. Our job is to provide input and recommendations based upon the data, and we can talk in incredible level of technical detail, but we want to assure that the client knows they have to make the decision. Third, set up what I call and many others call phase gates of design development. We make decisions and then we go and we do additional analysis. We go and do additional design. We go and do additional hydraulics. We go and do additional evaluation of materials. But at some point, we're going to establish these rhythm meetings or a point in time when we say best available information, understanding the business case, understanding the inputs, what will we do next? You have to be honest with your client and say to them, our desire is not to go revisit this after we've made this decision, unless the facts change dramatically. Because we've all been on these projects where we have really great ideas that are great for the next job, but are very costly to incorporate into the current job. The way to manage through that is understand the economic drivers, understand the technical drivers, and say, okay, we're going to make a decision here, and the best decision is to have a very crucial conversation right before you order the equipment. The key equipment, not every piece of equipment, but the key process equipment. And that process equipment may also involve ordering the electrical equipment. We're all still living in the electrical malaise of time, but that equipment is driven by the process equipment. So these phase gates, rhythm calls, roles and responsibilities, rhythm meetings, phase gates, and then you have to follow the basic fundamentals of project management to create a clear record for the project and an audit history. Let me tell you a short version of a long story. I was attending a meeting in Alexandria, Virginia about 6 weeks ago, and we had 4 owners talking to our group of water folk. We asked them, we provide you solutions. What are the problems we as water providers, water solution providers caused you? And the senior director, she said to us, when I cannot go back and summarize why a decision was made because there's no documentation to prove why a decision was made, it handicaps me like nobody's business. And it really struck the group. There were about 70 of us in the room, and it generated a tremendous amount of conversation about project management 101. And think about it in this regard. Management flux is a normal, customary part of many businesses. But in manufacturing, particularly in this type of manufacturing, people move from place to place to place, even within the same plant or even within the same company or the same industry. So the wonderful, great conversations we have with one another on a project to make decisions has to follow that recording part so that the next person who's equally capable but not as aware has the ability to catch up.
So, whenever we have the gift of hindsight, enlightenment always follows. So, I'm curious. Now that you've completed this project, you've now have the gift of hindsight. What were some things that you would have done differently?
Well, we would not have spent as much time on 12 economical studies because when I stand back and look at it from a statistical perspective, we were literally working in the single digit difference between one solution and another solution. But what it did do is it caused us a loss of time, and that wasn't helpful for their business. What I would also do differently is we thought we did a pretty good job of bringing our operations team to the table sooner. I would bring them in even sooner than that. But I would tell them that the role that they would play is so that they understand the playbook, not that they're ready to go on the field. And because it happened this way, we went through this design development, we went through this whole evaluation of the business case. We got to the point where we were 60% drawings. And then we brought the operations team in and said, okay, you've heard what's going on. Now you get to see what's going on. Please make comments so we don't do something weird when we go from this 60% guaranteed max and then create a guaranteed maximum price and go forward. The spool up for our operations team and particularly for our field leadership took longer because of the manufacturing environment they were working in. And we didn't provide enough foresight about that ramp up, whether that's background checking or site management or gate control or delivery of product. And those are the things that I would change.
What's your process for doing a postmortem, say? So we just completed this process. We want to make sure we're continuously improving every time we complete a process. So what is your process for continuous improvement?
We look at the 7 things owners like, and we evaluate how we did internally and with our design partners. The first thing an owner wants is scope. Did we deliver the scope that we promised? That takes input both from our team and our designer and our customer. And so we have to have, and we do, we have the guts to ask them. And maybe sometimes you're not always getting what you think you're going to hear, but do we deliver the scope? Secondly, how do we do on schedule and our promises that we made? Do we have enough foresight in terms of weather delays or deliveries or otherwise? Schedule compliance, certainly cost compliance. So scope, schedule, budget. Then we go to quality. What was the level of quality? What was the level of rework that had to be completed on the project? Whether that was go through all the divisions. Was that a concrete miss? Was it a structural steel miss? Was it a piping miss? Was it an electrical miss? Was it an insulation or a labeling miss? Quality. Where were we in terms of quality? What did we have to rework and how much did it cost us? Safety. How many people hours did we put into the project? How many safety incidents did we go through? Did we have any? And if so, what are those fishbone diagrams? So scope, schedule, budget, quality, safety, risk. Did we clearly identify the risk? Were the risks that we thought we in the beginning the same risks that we ended up with in the field? What can we learn? And then lastly, owner, we're going to be quiet, but after we ask this question, tell us what you thought. And I have to tell you, Trace, that's probably the hardest quiet time of any project because sometimes they don't want to talk and you just have to not talk.
I love those 7 steps. I encourage everybody to come up with their own 7 steps, if not just copy the ones that you just did, because it's continuous improvement. And I've worked with a lot of people that just don't use the data that they found on an existing project to make the other one better for everybody in all the areas that you just mentioned. So I appreciate you bringing those to us. Mike, I think we all learned from this interview, as of course we all expect every time you come on the Scaling Up H2O podcast. I want to make sure the Scaling Up Nation knows that we do have the paper that we referred to on our show notes page. So if you want to read exactly what we were talking about, that will be there. Before we move on to the lightning round questions, any closing thoughts that you have about your paper?
The closing thought would be understand that the paper for the conference is limited to 8 to 10 pages, and there's always more information behind what's in the paper. So if someone has a question about a gap, an incomplete thought, or something interesting, please have them reach out to me directly via phone, my email, which will be posted, or via my LinkedIn page.
I love that. We'll make sure to have all of that on the show notes page. Well, let's transition over to the lightning round questions. So these are round 2 questions, so a little bit more difficult than the first ones you were asked.
Okay.
Here we go. First question. What do you think the 3 books that everybody should read this year are?
The first one is called The Greatest Salesman in the World, and it's written by an author named Og Mandino. It was written back in the 60s. I will tell you, it is remaining relevant every day, and it doesn't have a thing to do with sales. Book number 2, a book by Winston Groom, a little bit older book, but it's called The Patriots. It's a story about James Madison, Thomas Jefferson, and Alexander Hamilton and their interactions in the 18th, 19th century. And why I believe that that's an interesting read is because it helps us understand where people don't agree all the time, but what they agree upon is the principle. And the third thing is there is an author named Adam Grant, and he wrote a book called Think Again. And it is a thought-provoking book to ask yourself, why do I understand what I believe I understand? And have I looked at the larger picture to see if I'm not just missing something because I think in a certain way?
Why do you think somebody should work in the water industry?
It's fascinating, it's fun, and it provides you a good fortune. I mean, it is a sought-after profession, and you can make a really good living, and we need people joining our industry.
What are you most looking forward to over the next 12 months?
Well, as you've already figured out, I compartmentalize. So collaborating with my clients I've got several key projects that they have been talking with us about. So there's about 6 projects that were the next 12 months that would be engaged. So that's one. Enjoying the growing family that I have. We are being blessed by our 6th grandchild.
Congratulations.
Yes, it's a wonderful, wonderful gift. I will say that. So that's in the next 12 months. And then I must say, flying. I've been doing a lot of flying.
That's on my list. I just started ground school, and I'm hoping maybe you and I can join each other someday. So
I'll be there.
We know you're going to be at the IWC. I know you're looking forward to the IWC. What are some other conferences that you're going to attend?
Well, there's the Indiana Water Environment Association conference in the state of Indiana. And then we have other team members going to Illinois, Missouri, Kentucky, Tennessee, or Kentucky, Tennessee is together, and Ohio. Those are all really valuable conferences for talking about what's current in those market spaces. We're also doing the same thing in New Jersey, Pennsylvania, Maryland, Virginia, North and South Carolina. Then there's the National Association of Water Companies, which is all the non-municipal owners that they serve hundreds of millions of people in the United States of America water. So they have different regulatory compacts and goals. And so those are probably the 3 that I'm going to attend. And I've just completed attending the National Design Build Institute of America conference. That was in the spring. And then we have also a Water Collaborative Design Association meeting that was coming up in September. So, yeah.
Well, Mike, it's always a pleasure to have you on the podcast. Once again, the Scaling Up Nation gets to learn from you. I'll make sure, again, the paper is up on the show notes page. Your contact information is on the show notes page. And I just want to thank you for returning to Scaling Up H2O.
Trace, truly delighted to be here.
Mike is such a great guest. I've always enjoyed speaking with Mike, and I met Mike at the International Water Conference, the IWC. I interviewed him prior to me speaking at the conference as their keynote speaker last year. And Mike, thank you. You were instrumental in getting me that honor to speak as the keynote speaker. And Mike and I have spoken several times. Just a great guy, full of information, and talk about loving this industry, loving what it is that he does and spreading that to anybody that will listen. So Mike, thank you for being a member of the Scaling Up Nation. Thank you for loving this industry and making sure that everybody you come in contact with knows about the industrial water treatment industry. That truly is one of my favorite things about going to conferences are the people that I meet. And I must admit, because I have this podcast, whenever I meet somebody, there's something inside of me thinking, how can I turn this into a podcast episode? So it's a double-edged sword. It's a blessing and a curse. But because of this podcast, I have met so many amazing people. And as I keep talking about, the Association of Water Technologies Conference was just last week. And so many people were saying how they get their information about the conferences that are coming up by going to scalinguph2o.com. scalingup.h2o.com, going over to our events page, here are some of the things that you will find. Well, first off, we are getting ready to celebrate Industrial Water Week. It's coming up, folks, so we don't have a lot of time for you to start decorating your offices, putting the new Industrial Water Week tires on your car. I don't know where that came from. I'm just making stuff up. So however you celebrate Industrial Water Week, get ready. October 7th through 12th, we're going to be celebrating each and every day with a brand new episode for you. And we'll have information about that on our events page and so many other things. So be sure to check that out. And folks, I love it during Industrial Water Week when you take pictures of yourself with equipment, with customers, with whatever and however you are celebrating Industrial Water Week, and you hashtag it with Industrial Water Week or IWW24. Make sure that you do that because I love seeing those posts and I know you do too. Somebody else who loves seeing all of those posts because he was the one that got this holiday started, well, that's our friend James McDonald. And here's a brand new installment of Drop by Drop with James.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment, you guessed it, drop by drop, together. In today's episode, I have a challenge for you.
Challenge accepted.
The challenge is calculate the holding time index on your cooling towers. Notice I said towers in plural. This is something you should know about all your cooling towers. My first question for you is, what is a holding time index and why is such a calculation important? What information do you need to calculate it? The holding time index can also be called the half-life or retention time. It is a measure of how much time it takes for a chemical that is added to a system to be diluted to 50% of its original concentration due to blowdown and possibly other water losses. This can be particularly important for biocides since some require longer contact times than others to be effective. Fast-acting biocides may only require a contact time of half an hour, while slow-acting biocides may require several hours. The holding time index can also be important for polymers in a system as well. A high holding time index means the polymer will be in the system longer, which can lead to the polymer losing its effectiveness as it is bound up or degraded. The equation for the holding time index isn't a hard one. It is simply 0.7 multiplied by the volume and divided by the blowdown rate. Be sure the unit of measure for volumes are the same for both the cooling tower volume and its blowdown. For example, use volume in gallons if your blowdown rate is in gallons per hour or gallons per minute. Lastly, the units of time that your final answer will be expressed in will be whatever follows the word per in the blowdown rate. If you used gallons per hour, your holding time index answer will be in hours. If you use gallons per minute, your holding time index answer will be in minutes. Now go out there and calculate those holding time indices. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Thank you, James, and thank you, Scaling Up Nation. I love that you tune in every week to listen to this podcast, and as promised, I'll have a brand new episode for you next week of Scaling Up H2O. Have a great week, folks. Scaling Up Nation, one of my favorite things to do is teach and coach people. I wanted to make video content that would help water treaters gain the confidence they need to take the next step in their career. And that is taking your Certified Water Technologist examination. If you've been in the industry for 5 years and are ready for the next step in your professional career, sign up for my CWT Practice Exam course. The course has over 130 videos to help you take and prepare for the CWT exam. Don't delay. Visit scalinguph2o.com/CWT prep to sign up for my CWT Practice Exam course. Again, that's scalinguph2o.com/CWT prep. I'm here to help you gain the confidence you need to take the CWT exam.